the syllabus. Please try to cooperate. So once again, good morning all.
Good morning, sir.
Yeah. Just I am going to share the syllabus and yeah, is this screen is visible? Is this screen is visible? Hello? Hello? Is this screen is visible?
Yes, sir, it is visible.
Yes, sir.
Now, this is the syllabus. Now, we are discussing about log-based protocols now. Here, we need to finish this much syllabus in the fourth unit, and we have 50 unit also. 50 unit is very easy. That's what, please try to respond quickly. And coming to your academic calendar, your second midterm exams are going to start from 15th July. Now we have very less time. I think 3 weeks of time is there for your second midterm examination. Are you clear?
Yes, sir.
Yeah. So that we have 3 weeks of time, and we have only 2 experiments in the laboratory. So that maybe the procedures and concepts. Only 1 week is enough, but we will take 2 weeks, and one more week also we can get for practicing and revision anything is required. And for this syllabus, we can get, as per my knowledge, 14, 10, I think 12 hours we will get. From today onwards, 13 hours, I think, along with today's. Okay, we will cover, but only the thing is you need to respond. Whatever the things I am asking you, please to respond so that I can move fast, so that we can discuss all the topics within the given prescribed time. Okay?
Yes, sir.
It is fine. Yeah, please. Now coming to the syllabus, coming to the today's topic, we already discussed about the lock-based protocols in the last class, correct? Even two-phase locking also we discussed. Here, what is the two-phase locking? Tell me. Any one of you, please. What is the two-phase locking? What is the two-phase locking? What it contains?
Transaction must hold its exclusive locks till it commits or aborts.
No. Two-phase locking contains two phases. The first phase is only for growing phase. The second phase is for shrinking phase. Means in a two-phase locking, the first phase, growing phase is nothing but you need to apply the locks. Okay, we cannot release any lock in this phase. That's the first phase. In a second phase, we need to release the locks. Means we need to no need to obtain a new lock. Compulsory, you need to release all the locks. You need to release in the second phase. So that is the two phases we are having in a two-phase locking protocol, which we discussed in the last class. Clear? All of you clear? Hello?
Yes, sir.
Here in that two-phase locking, if you want to use in the growing phase, all the locks, only the locks which are only exclusive locks, we are going to apply up to the commit or abort of the transaction. That is called as strict two-phase locking. Here, if you are going to apply exclusive lock and shared lock, both locks, means all locks held until commit or abort of the transaction. Such a type of locking protocol is called as rigorous two-phase locking protocol. These two locks are extension of two-phase locking. Strict two-phase locking is nothing but same as it is two-phase locking. Along with that, at the time of applying of or holding of the locks, here generally in two-phase locking, what happened in phase one, you need to obtain the locks. You don't need to release. Here same procedure, but strict two-phase locking. Here whatever the exclusive locks we are applied, those locks must be applicable until commit and abort of the transaction, not look for the phase two. Here, that those locks, whatever we are applied in phase one, those locks are available, that is the exclusive locks, especially in strict two-phase logging, must be available until transaction is commit or abort. So this is for strict two-phase locking. In rigorous two-phase locking, here whatever the locks you apply it. Maybe the shaded lock or exclusive lock, those locks never be released. Those two locks never be released until the commit and abort of the transaction. Such type of protocol is called as rigorous two-phase locking protocol. Clear?
Yes, sir.
Yeah, we discussed these things in the last class already. Just I am giving the some idea. Now coming to lock conversions. Here, when we are going to convert from one lock to another lock, means first phase. Here, when you go for the first phase, how locks are going to convert? Here, can acquire a shade lock on item. For example, if you are acquired a shade lock, not a problem. First phase, always you are going to obtain the locks, not going to release the lock. So that if you are acquired shade lock, yes, good. If you are acquired exclusive lock, yes, good. If you want to convert any lock, there is a chance only to convert shade lock to exclusive lock. That is, the upgradation is possible in a phase one. That is converting shade lock to exclusive lock. Here there is no chance of converting exclusive lock to shade lock. Means we are minimizing. There is no chance of minimizing, downgrading of the locks in a first phase, because as per the two-phase locking mechanism, we know always we are going to obtain the locks, so that we are going to upgrade the lock. Upgrade means shade to exclusive. There is a chance to convert. Understand the conversion in the first phase? Hello? All of you understood? Hello? Hello?
Yes, sir.
Now, the coming to the second phase. What is the second phase? Can you tell me? What is the second phase? Hello?
Shrinking phase.
Yeah. Means shrinking. Means we are going to release the locks. Correct. We need to release the locks in the second phase. Yes or no? Hello? Hello?
Sir.
Now, in this shrinking phase, we need to release the locks so that we can release the shade lock. You can release the exclusive lock. Now, if you want to convert a lock, that must be converting from exclusive to shade. Means you are downgrading. You must be downgrade the lock conversion in a second phase. If you required to conversion, that must be convert downgrade only, not for upgrade, because the downgrade means reducing the lock intensity. Yeah, that reducing means if the lock is exclusive, then you downgrade it to shade lock. So that is a lock conversion for first phase and second phase. All of you understood? All of you understood? Hello? Hello?
Yes, sir.
Yeah. Now, here how the locks are going to automatically acquisition. It's simple. When a transaction TI issues the standard read or write operation instruction without explicit lock cost, directly it is going to acquire the lock. Simple. If TI has a lock on D, this is read lock I'm telling, for reading of object on D, how the locks are going to apply when I'm going to perform read a data object D. Here, if it is the very simple code, in your C programming, very small thing you can write. If TI is a transaction as a lock on D, then read D. Here, if the shade lock on D, then only we can read the D. Else, if there is no lock, means there is no chance, we don't have any lock on D from TI, then we can begin, we can apply the lock if necessary, wait until no other transaction has lock on exclusive on D. Then grant TI lock on S on D, then you can read the D. Here, if there is a lock, you can read. If there is no lock, you can apply exclusive lock or maybe the shared lock on D, then you can read. Because you know, if you are going to apply exclusive lock, yeah, sorry for the inconvenience. My side just power gone so that my internet, I lost my internet. Again, I connected. Okay. Uh, is this audible? My voice is audible?
Yes, sir.
Yeah. Yeah, screen is visible.
Yes, sir. It is.
Yes, sir.
This code is understand. This code is understood, everyone. I don't know whatever I explained. Are you heard or not? Shall I explain again?
Yes, sir.
Yeah. Now simple. When I wanted to read object D, here when I want to read, then compulsory you need to apply a lock. Here maybe either shade lock or exclusive lock. Here that's what I don't know, so that the lock is already applied or not. So that I am going to check if TI transaction as a lock on D. Yes, if it is true, then read D directly. If there is no lock on D from TI, then you have to apply the lock. Else, if you want to apply exclusive lock, then you can apply exclusive lock on D. Otherwise, if you want to apply shared lock on D, yes, you can apply shared lock, because any exclusive lock also you can read or shared lock also you can read. So after applying of this, any one of the lock, then you go for the read operation. All of you clear? Very simple code, if and else block. All of you clear this? Hello?
Yes, sir.
Hello? Yeah. Now, if I want to perform write operation, you know, tell me, if you want to perform write operation, what lock you need to require? Which lock you need to require? Hello? When you want to write operation, what type of lock you need to require before writing of your data on D object? Hello? Hello?
Exclusive lock.
Exclusive lock.
Yeah, exclusive lock. If there is a shared lock, you need to update it, because you cannot write the data with help of shared lock. So that we need to exclusive lock. So that you need to check if that particular transaction TI already locked exclusive lock on D or not. If it is already exclusive lock on D, so that you can write. If there is no exclusive lock, means else. Then if TI is having shared lock, but if it is having shared lock, it is not a chance to write operation. So that you need to upgrade from shared lock to exclusive lock. Otherwise, there is no any lock, shared lock, exclusive lock on object D. Then you apply the exclusive lock. Then you write the data on D object. Are you clear? Understand?
Yes, sir.
If you want to write anything on D object, you need to check that object is having or already applied exclusive lock by TI transaction. If it is there, then you write directly without any verification. If it is not there, exclusive lock on object D, then you need to check that object already having shared lock. If it is having shared lock, then you need to upgrade it from shared lock to exclusive lock. Then you can write it. If it is not having even that shared lock also, then you need to apply exclusive lock. Then you can write the data on the object. This is the procedure or automatic acquisition of locks, write and read operations. Are you clear now?
Yes, sir.
Yes, sir.
Yeah. Now already I told you, after all locks are released, our transaction are going to commit or abort. This is a common procedure after releasing. Compulsory before commit or abort, all locks must be released. So then only you need to go for commit and abort. That is minimum procedure. Are you clear? Clear this?
Yes, sir.
Yeah. Now coming to implementation of lock. So this is very important topic. Here how we are going to implement the locking. Here we have a lock manager. Here it is going to implement a separate process to which transaction send locks and unlock requests. Compulsory. Where there is a lock manager is there in your DBMS architecture also. I mentioned lock manager part. Here that lock manager is going to verify here the locks which they are applying locks and they are releasing locks wherever it is required. Like that, this lock manager is maintaining one lock table. This lock table is a data structure which is going to maintain which object is requesting lock and which object is releasing the lock and which object is already locked and which object is the lock is releasing. Then everything is maintained by lock table. Are you clear? Lock manager is maintaining a lock table. Based on the lock table only, the lock manager is going to manage the locks. Here to avoid the deadlock mechanism, because one object is locked by one transaction. Now T2 also want to same object, but already it is locked. That has to release, right? So that only T2 can access. Otherwise, deadlock will occur. To avoid this deadlock situation, the lock manager always verifying which is requesting and which is waiting and which is going to release and which transaction is committed or aborted. Everything is going to maintain with the help of lock table. The lock table is nothing but it is a data structure. I will tell you how the data structure will work, this lock table. First of all, understand lock manager. Are you clear now? What is the importance of the lock manager? All of you clear?
Yes, sir.
Now the lock table is nothing but, already I told you, it is a data structure, nothing but a hashing mechanism it is going to follow. Hash table it is going to follow. Now here this is a linked list mechanism. Here whenever one particular transaction, for example, this is T1, T2, like that, it is there, so many transactions are there. Here any transaction wanted to access any lock on any particular object, then automatically the lock is going to here applied on that. Here always the new lock is going to add end of the transaction. Here the black color is the lock is granted. The white color box is waiting for the lock. So that is nothing but block rectangles indicates granted locks. White ones indicating waiting request. Here this T2 is waiting lock for this I23 object. Here T23 here waiting for I4 object. Here TIT is already the lock is there, it is doing their process. T23 it is doing their process. Here like that, here we can understand the locks, whatever the locks are achieved. Here when you are observed, here the waiting locks are always in the end. Means whenever the new lock want to access any transaction, that is the next only. If any lock is there, it will be a block. Now any other transaction wants the object, then it will be waiting state. Like that, every new transaction must be in the last. Lock table also records the type of lock granted or requested with help of this, and a new request is added to the end of the queue of request for the data item and granted if it is compatible with all earlier locks. Unlock requests result in the request being deleted and later requests are checked to see if they can now be granted. If transaction aborts, all waiting are granted requests of the transaction are deleted. For example, this transaction is maybe aborted. So that all waiting and granted everything will be deleted indirectly. Lock manager may keep a list of locks held by each transaction to implement this efficiently. This is the way the lock manager is going to implement a lock table with help of data structure. Here that locks are going to work with help of lock table only. All of you clear? Already I told you, wherever you go, any technology implement, there is a data structure. Because we need to arrange the data. All of you clear now this lock table and lock manager? All of you clear about this lock table and lock manager? Hello. All of you clear about lock
Yes.
manager and lock table? Very important. All of you clear?
Yes, sir.
Hello?
Okay.
Yeah. Now next one is the graph-based protocol. Sure, another way of representation of our two-phase locking is a graph-based protocol. With help of graph-based protocol also we can represent our two-phase locking. This is another representation, alternative mechanism. Why this graph-based protocol is? It is easily understand everyone. Graphically, if you represent, you know already the graphs which trees and graphs which we discussed in the data structure concept. Here, when we and even ER models also graph based representation. When we are going to observe anything, we are going to show in a graphical view, the end user can understand very easily. In the same way, the two-phase locking also we can represent with help of graph-based protocols, so that if we are going to have a set of partial ordering, means the data items if you are having D1, D2, D3 up to Dn, we can use a D. Now if Dj is depending on Di, so that we can write Di determines to Dj. Means here first of all the transaction is accessing Dj, then it moves to sorry Di, then it moves to Dj. Like that, here when any data object is depending on another data object, we can write Di determines to Dj. So that procedure will come a graph D1, D2, next D3. Like that, here this will come, it will be shown as a graph. Here that is a database graph. You can tell that is a database graph. Sometimes it is called also a tree protocol also, because simple kind of if you take, maybe it follows only hierarchy model. If it follows this hierarchy model, then we can tell this is a, already we know here all trees sometimes all trees sometimes we can call as a graph, but all graphs we cannot call as a trees, because always trees follows hierarchy structure, graphs follows any structure. It will be start from any node and it will be end to any node. But trees always start from root node. Okay, so that all trees we can call as a graph, but all graphs we cannot call as a tree. You know very well. Okay, so that the arrangement, the procedure, the movement from one data usage from one transaction to another transaction, how we are going to do that, you can print in a graphical structure. So that is called as graph-based protocols. Are you clear? Are you clear? Hello? All of you clear this? Hello? Graphs and trees, all of it clear, same data structures only. Hello? Hello?
Yes, sir.
Is this my voice is audible or not? Hello?
Yes, sir. Audible.
All of you clear about this representation of graph based
Yeah.
protocol?
Yes, sir.
Yes, sir.
Hello? All of you, are you clear this? Okay. Now same, I told you just now, the representation, we can, here it is a directional graph, correct? Hello? Hello?
Yes, sir.
Yes, sir.
I want a response. It is a directional graph. Sometimes you can take, if it is a tree also. So already I told you, all trees we can use as a graph. Then if you take, if it is a tree, then always it will be start from the root node and compulsory after A it moves to the B or maybe the C. Like that only it will be. Means when I wanted to access the object as a transaction T1, I want to access the data object. Now compulsory, before that I need to access A, then B, then D. Here I cannot access D directly. Are you clear? In the tree data structure. Yes or no?
Yes, sir.
Hello? Yeah, this is what exactly this information already you people are aware in a data structure so that easily you can understand. If it is a graph, for example, if it is a graph, now if I want to access D as a transaction T1, if I want to access D, here is there any requirement or you can directly access D?
We can directly access.
Yeah, because here it is not a tree. The tree always starts from root node. Here, but in a graph, you can take any node as a start node so that we can access. So this is the difference. Here, wherever the requirement is required, you can use either graph or tree protocol instead of writing two-phase locking also. All of you clear this? All of you clear? Nothing is there.
Yes,
You
sir.
know already data structures. Yeah. Now the next topic is timestamp based protocol. Very important. Already you people are aware in your operating system in a scheduling algorithms. In scheduling algorithms, same mechanism. Here the timestamp based protocols is nothing but here in schedule, whenever you are going to design in your database management system, transaction schedule, when you are preparing, you need to mention a timestamp. Timestamp means nothing but a time period, time span. Here, how much time I need to do for write operation, how much I need to do for read operation. That timestamp is nothing but the time you need to specify. Here, for every operation, you are going to specify the time. For example, you are given for read operation, time is 10 minutes. Now the transaction T1 is going to read only 10 minutes of that object. Once 10 minutes is over, automatically T2 is going to enter and read here whatever the time it is mentioned by T2 transaction is the time of locking. Here we are applying along with the log and time so that that much time only it is going to read like whatever your class schedule we are prepared here along with the schedule log that is a DBMS class from 12:20 to 11:20 to 12:20 in Wednesday. Now the time also we are fixed. The time stamp is 1 hour time. Here 1 hour time automatically the things are going to close. The same way the timestamp based protocols are going to work like that. Then what is the advantage of timestamp based protocol? Generally in a log based protocol, what happened? Here T1 transaction apply the exclusive lock on A. Now T2 wanted to apply again exclusive lock on A. But until T1 releases the locks, T2 need to wait. Yes or no? Yes or no? T1 need to release that exclusive lock on A, so that only T2 is going to apply lock and it will be perform its operation. Yes or no?
Yes, sir.
Hello? So that T2 is waiting until T1 is going to release the lock. There is a chance of deadlock because T1 is not going to release the lock and T2 is not going to perform their operations because T1 is not releasing. So the T2 is waiting continuously. Then there is a chance of deadlock. Yes or no? Yes or no?
Yes, sir.
Hello? So that we need to avoid that situation. The timestamp based protocol is going to avoid that situation. That whenever T1 wants to write object A, it is applying exclusive lock along with the timestamp. The timestamp is 5 seconds, for example. Now the T1 is going to apply write exclusive lock and it is performed only 5 minutes write operation. Once 5 minutes is over, that particular lock is going to release. Now after 5 minutes, immediately T2 is going to acquire and it will be performed. Again apply exclusive lock along with the timestamp, that is 3 seconds. The 3 seconds is completed, whatever the write is done, it is done up to that only. Then it is going to release. So this is what exactly we are maintaining the time size. Automatically, the another T2 is not going to wait after 5 minutes. Till once the 5 minutes or 5 seconds are completed T1 transaction, the A object is going to release it. Then T2 is going to access. Means there is no chance of waiting more. So that there is a chance to avoid the deadlocks with help of timestamp based protocols. Clear this? The advantage now understood why timestamp based protocols instead of two-phase locking. All of you clear this? Hello? Hello?
Yes, sir.
Clear this time? Why timestamp based protocol is required? All of you clear?
Yes, sir. Clear.
I'm asked. Yeah. Now coming to the point. Each just I am reading. Just whatever I told you is over actually, but again I am reading. Each transaction is issued a timestamp when it ensures the system exactly. If an old transaction TI has timestamp TS, TS means timestamp of TS transaction. A new transaction TJ is assigned timestamp TS of TJ such that TS of TI is less than TS of TJ. Exactly. Yeah. When already we are applied a transaction TI, that is old timestamp, means 5 minutes we are given. Now new timestamp TJ on 3 seconds we are given. Here generally, here when it will be performed TJ, it will take more time. Why it is more time? 5 plus 3 seconds is required to complete TJ. The TI is required to complete only 5 seconds, but TJ is required to complete 5 plus 3, total 8 seconds. So that if you do any timestamps for the transaction, they're compulsory. The old timestamp completion time is less than the new timestamp transaction time is. Are you clear this? The meaning? All of you clear this? Logic, very important this. The TI is required only 5 seconds to complete the transaction, but TJ is required whole timestamp plus because it has to wait until 5 seconds. After that, remaining 3 seconds. Total 8 seconds need to wait to complete the TJ. So that TJ is greater than the TI timestamp. All of you clear? All of you clear?
Yes, sir.
Time is running, please. Yeah. Now we know the protocol messages concurrent execution such that the timestamp determines the serial. Exactly. If there is no chance of concurrency mechanism, if there is a serializability mechanism only there in this timestamp base. Because here, if you are going to write T1, T2, then you are given T1 some time, after that T2 some time. Here compulsory T2 has to wait until T1 time completes. So that there is no chance of concurrency. There is only the serializability must be followed in this timestamp based protocols. Are you clear? All of you clear? Hello? Hello?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
Yeah, we have two categories of timestamps. One is write timestamp, another one is the read timestamp. So what is the write timestamp? The largest time is required to complete the write operation on queue successfully. Read timestamp means the largest time is required to complete the execution of read of queue successfully. We have two categories of timestamps. One is for writing of operation, performing write operation requires W timestamp of Q, and a read operation of Q is required read timestamp of Q. Here both you need to take largest timestamp. Don't go small, you need to take maximum time. That is what write timestamp and read timestamp. Clear? Two timestamps are clear? Hello? All of you clear? Because we have
Yes,
only
sir.
two operations. One is read operation, and one is the write operation. So that we have only two timestamps. When you are going to perform timestamps, we have only two operations. Already I told you, read and write. That's why we need two timestamps. When I want to perform read operation on queue, then you know timestamp of Ti is less than or equal to, compulsory it must be less than or equal to write timestamp of Q. 100% maximum times maybe it is equal or less than write timestamps. When you want to perform this, the Ti needs to read a value of Q that was already overwritten. So this is what exactly will be happen. If we go for the timestamp of Ti is greater than or equal to write timestamp, then you can read. Here, timestamp of Ti value transaction, total timestamp of Ti is less than of write timestamp, then there is a chance of already the data we can read and write also we can do it. But when the timestamp of total transaction is greater than of write timestamp, then we can perform only read operation. Understand? Reading is take very less time, right? For writing. Hello? Reading is going to take less than for the writing, right? Hello?
Yes,
Yes,
sir.
sir.
Hello? Read up. Read operation is going to take less time. Yeah. So that's why when I wanted to read, now I'm going to measure the total timestamp with the if total timestamp of transaction is less than or equal to, maybe the equal to, write timestamp, then we can perform read and write without any confusion. But when timestamp of total timestamp of transaction is greater than of write stamps, you can perform only read operation. There is no chance of write operation. Clear? Clear? Hello? All of you clear? Hello? Response is required. All of you clear this?
Yes, sir.
If you are having doubt, you ask me. Yeah, yes. Please, if you are having doubt, you ask me. I will explain. Don't worry. Now coming for the write operation. Simple. Again, we have categories. Here, when we want to perform write operation with the timestamp based protocol, here the total timestamp of PI transaction is less than read timestamp because we are performing write, we are comparing with read. If you are performing with read, then we need to perform with write operation timestamp. Already told you, right? If total timestamp of transaction is less than read timestamp, here there is no chance to write there is no chance to write operation because it is rejected because the read timestamp is taking more time on total timestamp. So that write timestamp cannot be performed. It is not possible. If total timestamp is less than our write timestamp, yes, we can perform the write operation. Here, when there is a rollback is going to happen, here there is a chance to write the perform the write operation when we are going to apply, when we are going to check the total timestamp is less than the write timestamp, so that we can perform. Otherwise, the write operation is executed and write timestamp is set to total timestamp of Ti. Here, when we are comparing with read timestamp is greater than of total timestamp, here it never be executed write operation. It will be directly rejected. Clear? All of you clear? Here, this case cannot be done. Maybe the write timestamp is greater than of total timestamp will work, or write timestamp is equal to total timestamp. Also, our write operation will be performed. All of it clear?
Yes, sir.
Yeah. Now the example very simple. If you are going to give a timestamps 1, 2, 3, 4, 5, means if you are going to give T1 time is 1, then T1 is going to execute only one second or 1 nanosecond or whatever the time stamp they are. Maybe you take 1 second, seconds only you take. Now T1, if they are given T1 for 1, only it will be execute only T1 1 second. Here, once 1 second is over, then it will move to T2. For example, if you take simple way, you can take it here 1 second, one operation. Then like that we can feel, then we can understand how many operations we do. Okay? Shall we do that? Shall we do that? 1 second, you feel one operation will be performed. Only that we can do that, then we'll check. Are you clear?
Yes, sir.
The order I am taking, this is T1, this is T2, this is T3, like that, T5. Otherwise, you can change your order. Generally, I am taking same order. Then here T1. Here first what happened? T1 will be executed, given within 1 second. Here after 1 second, again it moves to T2, right? So how many seconds are given for T2? How many seconds are given for T2? Hello?
1
Hello?
second.
T2 is given 2 seconds, right? Then one operation is going to executed. If there is no next operation, then 2 minutes is waiting. Then it moves to the T3. Are you clear? Are you clear? Hello.
Yes, sir.
Right. Next, again, coming to the T3, 3 seconds are there. Here, 1 second, 2 seconds, 3 seconds. Here it is over. Then it moves to the T4. Now, 4 seconds. 4. 1, 2, 3, 4. Then it moves to the T5. Here there is no data. Means reading means there is no data. T5. Now, just I am showing how it will be work. Here 5 seconds. 1, 2, 3, 4, 5. Now it is over. Once it is done, again the term comes to the T1. Now T1 again 1 second. So what happened? It will be check this. Next T2. Again 1 and 2. Now T3. 3 seconds. Here 1, 2, 3. Now T4. 1, 2, 3, 4. Now T5. 5. 1, 2, 3, 4, 5. Now go to T1. Here like that, it will be execute. Here there is no waiting. Here no transaction is going to wait. Here once it is going to done, again go back T1. 1 second. Like that, it will be do parallelly. So this is what exactly the timestamp based protocol. Here even you can reverse it. Okay, you can assign 5 seconds to T1. Whatever the order you can do it, you can do it. Here this is the way. Means no transaction is not waiting for another transaction, so that there is no chance of data loss. All of it clear? Clear? Hello? Hello? All of you understood this? All of you understood the timestamp? Yeah. Now, here the correctness of timestamp ordering. Simple, already I told you. The transaction with the smaller timestamp determines to the transaction with larger timestamp. Yes, 100%. Here, always the smaller timestamp is executing faster and the larger timestamp is taking slow. So that this larger timestamp is depending on smaller timestamp only. But this is what exactly we can do it. Correct? Is it correct? Hello? Whatever the example I discussed just now, yeah, smaller always will be done faster, larger will take time. That's why always the larger is depending on smaller only. Clear? Clear?
Yes,
For
sir.
this, there is no chance of deadlocks. Already I told you. Why? Because once the transaction execution is done, the time is over, then it moves to next, 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 next. There is no stop. Once the time is over, it will move to next, next, next. No transaction is going to wait more time. Automatically, it is going to release the lock. So that here it is freedom from deadlocks as on the transaction never waits. No transaction is going to wait. That's why that is a even it is a cyclic precedence graph if you are going to observe because T1 moves to T2, T3, T4, again T5, again T1, T2. So like that it is moving. Here, if you take every transaction is a node, then like that it is going to move. So that's why it is a, you can feel it is a cyclic, exactly, you will get the cycle, right? The T1, T2, T3, T4, T5, again you are moving T1, T2, T3, T4, T5, again you are moving T1, T2, T3. The cycle we are getting here, and it is a graph you will get. That's why it is a cyclic or cycles in the precedence graph. That is why here when again moves like that. So that is what exactly we cannot get any deadlocks, and there is no chance of even cascade free. We cannot move rollback also because once the transaction is over, then moves to next, moves to next, moves to next, moves to next. That's why there is no waiting time. That's why you cannot get any rollbacking, you cannot get any deadlock, or you cannot get any problem. Even we no need to require any recoverable also because time is over, you need to move next. Time is over, you need to move next. So that it is a good mechanism when we are going to observe from the previous techniques. All of you clear? All of you clear?
Yes, sir.
Yeah, now comes to Thomas Wright rule. So sometimes some interviews people are asking for this timestamp based protocol. The Thomas is one scientist. He has given one rule for writing at the time of timestamp based protocol. That is, you can tell this is a modified version of timestamp ordering protocol also sometimes. It is not there in your syllabus, they are not mentioned. But even though sometimes it is very important in interviews, some other places and industries, so that I am giving only one adding point is there. If that is only the write operation, they are given some upgradation, some circumstances they are given. Only the thing is, just I am reading, just you can remember that enough. Nothing is there. When TI attempts to write data item on queue, for example, any one of the transaction wants to write some data on a item queue, you need to check if timestamp of TI is less than write timestamp of Q. Means the write timestamp is more time is required comparatively total timestamp of TI transaction. Then TI is attempting to write an absolute value of Q. So that is called, the TI is trying to write a absolute value of a Q. Means the write timestamp of Q is taking more time than total timestamp of that transaction. Here now the TI must be writing a absolute value of Q. Here this is what Thomas Wright rule, because if you are performing a one transaction this much time, but maybe the write if you are going to apply on this transaction, it is taking more. The total timestamp is this, but write operation performed it is taking this. means it is taking more. So that maybe the Thomas is mentioned that the write operation, whatever it is doing, that is the value, the whatever the value is writing, that value must be absolute value of that particular queue they are telling, rather than rollback TI as the timestamp adder. If it is not like that, it will be rollback. This write operation cannot be ignored. So this is one. If it is not like that, the absolute value is not there, it must be rolled back. What is the use? No use. If this is what Thomas is given this rule when the write timestamp is taking more time than the total timestamp. If the write operation is a absolute value, it is writing on the object. All of it clear? Even you can remember very easily, because sometimes people are going to ask this Thomas write rule. All of you clear this? Hello? Hello?
Yes, sir.
Hello? Here we completed timestamp based protocol. We have so many topics still. Okay, validation multiple, yeah, what we will discuss. Okay, now validation based protocol is there. We will discuss these things in the next class, because even time is running, we cannot finish up in the given time. Okay, remaining topics we will discuss in the next class. So now all of you understand time stamp based protocol now?